Introduction. Resistance is an essential characteristic in electrical circuits that determines the flow of current. In this exploration, we will delve into the concept of resistance and examine how resistance levels can vary across different types of resistors. We will also explore the factors that influence resistance and their impact on the overall performance of electrical circuits. Understanding resistance. Resistance is the opposition offered by a material or component to the flow of electric current. It is measured in ohm, and represents the ratio of voltage across a resistor to the current flowing through it. The higher the resistance, the lower the current for a given voltage. Resistors are passive electronic components designed to provide a specific amount of resistance in a circuit. Factors affecting resistance in resistors. 1. Material. The type of material used in a resistor greatly affects its resistance. Different materials have varying electrical properties, such as conductivity. For example, metallic conductors like copper and aluminum have low resistance, while insulating materials like rubber have high resistance. Semiconductors fall in between and offer variable resistance depending on their doping levels. 2. Length and cross-sectional area. The physical dimensions of a resistor, specifically its length and cross-sectional area, play a significant role in determining its resistance. The longer the resistor, the greater its resistance, as electrons have a longer path to travel. Conversely, wider cross-sectional areas reduce resistance since they provide more paths for current flow. 3. Temperature. Temperature has a notable impact on resistance. Resistivity, a property intrinsic to a material, usually increases with temperature. This means that the resistance of a resistor tends to increase as it gets hotter. However, this relationship is not universally applicable, as certain materials, such as thermistors, exhibit negative temperature coefficients where resistance decreases with increasing temperature. 4. Resistivity. Resistivity is an inherent property of a material that defines how strongly it resists the flow of current. Different materials have different resistivities, which directly contribute to their resistance values. For example, materials with high resistivity, such as nichrome, are commonly used in heating elements, where resistance is desired. Types of resistors and their resistance variations. 1. Carbon composition resistors. Carbon composition resistors are made of a mixture of carbon granules and a binding polymer. These resistors have moderate resistance variations due to manufacturing tolerances, ranging from 5% to 20%. However, they are popular for their stability in terms of temperature coefficient and long-term reliability. 2. Metal film resistors. Metal film resistors are made by depositing a thin film of metal alloy onto a ceramic substrate. They offer higher precision and lower resistance variations, typically within 1% to 5%. Metal film resistors have excellent stability and low noise levels, making them suitable for precise applications such as in amplifiers and precision measurement circuits. 3. Wirewound resistors. Wirewound resistors consist of a resistive wire wound around a ceramic or fiberglass core. They provide high resistance values and low temperature coefficients. Wirewound resistors offer excellent precision and can have resistance variations within 1% to 5%. They are commonly used in power circuits, where high power dissipation and stability are required. Conclusion. Resistance levels in different resistors can vary due to various factors, including the material used, length and cross-sectional area, temperature, and resistivity. Understanding these factors is crucial in designing and selecting resistors for specific applications. The type of resistor chosen depends on the required precision, stability, noise levels, and power dissipation in the circuit. By considering these factors, engineers and designers can ensure optimal performance and efficiency in electrical circuits.